So this is the second part of section 4.1. I think it's going to be short, hopefully not too bad. The problem that's on the screen right now has a round, I guess it's a target that we're going to throw a dart at. And this target is broken up into 3 sections, but they're not equal size. The red and the blue sections are a quarter of the diagram, and the purple is a half the diagram. And we're going to be asked to answer questions about probabilities and what we're simulating is throwing a dart at this circle. And in order to answer probability questions, if I want to do it properly, or if I want to explain it kind of being consistent with the theory, I need to create a sample space. And if we're using a sample space to compute probabilities, every element in the sample space needs to have the same probability of happening. And if I throw a dart at this diagram, I'd have a better chance of hitting purple than red or blue because the purple region is larger. What I'm going to need to do is separate that purple region, cut it in half, and make 4 equal regions. And now I'm going to create a sample space for what could happen, and I'm going to abbreviate with just initials. So when I throw the dart, I could hit that red region, this blue region, or either of those purple regions. Now each of the 4 regions has the same chance of being hit because they're the same size. If I wanted to do problem 32, find the probability that the dart lands in the red region, technically I should probably create a subset of the sample space, and the subset of the sample space is going to have the elements in the sample space that fit this description, and that description is red. And the probability that the dart lands in the red region can be found by taking the number of elements in the sample space that are in the red region, which is 1, divided by the number of elements in the sample space. The answer would just be 1 in 4. When you go to do your problem 31, if you haven't already done it, the answer is going to be 1 in 4. And I probably wouldn't even show any work. I probably would just write an answer down without any work shown. For 33 and 34, it asks a not. And so for my 34, the probability that the dart does not land in the red region, I'm going to create a subset of the sample space. I'm going to call it not red. And the elements in the sample space that I created that are not red is the blue and the 2 purple regions. The probability that the dart lands in the not red section is going to be the number of elements in that set, which is 3, divided by the number of elements in the sample space, which is 4. My answer is going to be 3 and 4. I believe your answer is also going to be 3 and 4 if I did it right on my key, and I have 3 and 4 written down. So we can certainly do probabilities by creating sets, a sample space set and subsets, but realistically this kind of feels like overkill, and let me do the next set of problems without making maybe the set so much. So this is a little bit trickier, and it's really hard to read. So here's another spinner in this case as opposed to a dartboard, and in this problem this spinner is going to be spun, and we're going to find the probability it lands in a certain color. There's one pie, or one region, that's yellow. It's barely readable, but there's another region that's red, and then the rest of this circle is all blue. And in order to answer probability questions, all the pieces of the pie have to be the same. So I'm going to have to divide this up into equal regions, and each one of these regions, because it's in the blue area, I'm going to call blue. So if I wanted to find and answer probability questions about what color the spinner is going to spin in, the sample space that I'd be worried about would have 1 red, 1 yellow, and 1, 2, 3, 4 blues. When I go to answer my probability questions, The denominators are going to be 6 because there's kind of 6 regions, equal-sized regions for this spinner. So I spin the first question, 36. What's the probability if I spin this, it lands in the red region? And I can just write the answer down. I know the denominator is going to be 6 because I've broke this pie into, or this circle into 6 equal spots. The numerator needs to be the number of red regions, and there's 1 red region, so the answer is going to be 1 in 6. Since this is black and white, you can't see the colors. If you open this up on my website, you'd actually see the colors. I'm sure I took this spinner from Google Images. I have an answer written down for 35. I have the answer 2 and 3 because I asked for a reduced fraction in terms of my answer, and that's what your fraction should reduce to. If we want to look at 37 and 38, I'm going to do 37, the probability that the spinner doesn't land in a red, and for it doesn't land in a red, it would count the yellow and the 4 blues. So there's 1, 2, 3, 4, 5 of the regions when I made them the same size that are not red out of the 6 regions. My answer for 38 is going to be 5 and 6. For 37, I wrote down 1 and 3 for your answer. All right, 39 through 42. Each individual letter of the word Mississippi is placed on a piece of paper, and all 11 pieces of paper are put in a hat. If one letter is selected at random from the hat, find the probability that. So I need to create a sample space. I'm going to take each of the letters from the word Mississippi and put them in a hat, which means I'm going to have 1 M, 1, 2, 3, 4 I's, 4 S's, and 2 P's. So in my hat, there's going to be 1 M, 4 I's, 4 S's, and 2 P's. So these are the letters that go in my hat. There's 11 of them. When I go to answer a question about this, I know when I'm answering a probability question that the denominator is going to be 11 because I'm picking one letter from the word Mississippi that are each on a piece of paper in a hat. Each one of these letters has each one of these letters is on a slip of paper. There's 4 slips of paper with S, 4 with I, and each slip of paper has an equal chance of being picked. When I go to answer a probability question, the denominator is going to be 11. For your problem 39, the probability that an S isn't selected, the numerator needs to be the number of letters in the here that aren't S's, and I think there's 2 P's, 4 I's, and 1 M. I believe there's 4, 6, 7 letters that aren't the S's out of the 11. When I go to do my 40, I can do a sample subset of the sample space. I'm going to say not P, I, and that set, I'm sorry, I'm going to do the set P, I, which means the set that contains the P's and the I's, because I'm finding the probability that an I or a P is selected. And in this grouping, there's 4 P's and 2 I's. My numerator for my probability, the probability that I get a P or an I, is going to have 6 because there's 6 letters that fit their I or a P. My answer for my probability that I get an I or a P is going to be 6 and 11. 6 because there's 6 letters in the set that are I's or P's, 11 in the denominator because there's 11 slips of paper in the hat. For your problem 41, you should be able to give it a go. I wrote an answer of 0 down because the probability of picking a W, I need to form a fraction to do this. The denominator is the number of letters in the hat, which is 11. The numerator is the number of letters that are W, and there's no W. So your fraction is going to be 0 and 11. The probability is going to be 0. My fraction for 42, the question is, what's the probability that the letter W is not selected? Well, I'm going to form a fraction, and the numerator needs to be any letter from the sample space that's not a W, and all 11 letters are not W. So each one of these 11 letters would classify as not W. So there's 11 different objects in this sample space that would classify as not W. That's the numerator. The denominator is also the 11 objects in the sample space. And my answer for 42 is going to be 100%. The next few problems are tables, and they're a little bit trickier, but they're not that tricky. So in this table, I'm sure I just made this up. So refer to the table for problems 43 through 46 that show the results of a survey regarding the manufacture of cars driven by the people who were interviewed. So this table shows that men and women were asked if they drove American cars or foreign cars. I'm assuming every person surveyed had a car because I didn't have any no cars. So here there were 345 men surveyed. 260 of the men had American cars, 85 foreign. There were 370 women surveyed. 273 had American cars, 97 had foreign. 533 people had American cars, 182 had foreign cars. There were 715 total people surveyed. So let me try to answer a question that's a little bit harder. So if one person who completed the survey, so from this group, is selected at random, determine the probability the person selected is, and what's the probability that a person that's selected is a man? So I would say the probability that a person selected is a man is going to be formed by making a fraction. In the denominator, it's going to be the total number of people that completed the survey. In this case, it's 715. And in the numerator, because I want to find the probability of the person selected as a man, it's going to be the total number of men that completed the survey. In this case, it's 345. So for your problem 43, a non-reduced fraction answer is 345 over 715. I don't care to reduce any fractions by hand, so I'm just going to do it on my calculator. And for an answer, I get 69 over 143 for your problem 43. For my problem 44, the probability that somebody drives an American car, I'm going to form a fraction. The denominator of the fraction is going to be the 715 people that were surveyed, and the numerator of the fraction is going to be the number that drove an American car, which is 533. I don't think that fraction reduces, but I'll give it a try. 533 divided by 715. Math, enter, enter. Oh, it does. The answer for my problem 44 should be 41 over 55. In a few sections, we're going to revisit table probabilities, and they're going to be a little bit trickier. So get good at these before we get to the ones that are a little bit trickier. All right, so for your problem 45, you're trying to find, if I pick one of these people, what's the probability that the person is a woman that drives a foreign car. For my 46, I'm going to find the probability that if I select one of these people, that it's a man that drives an American car. I'm going to form a fraction. There were 715 people surveyed, so that's going to be the denominator. The numerator is going to be the number of men that drive American cars, and that's going to be that number there, because in this survey, there were 260 men that drove American cars. And again, I'm going to reduce this fraction to get my answer. So I'm going to go 260 divided by 715, and then math, enter, enter. My answer for problem 46 is going to be 4 and 11. If my answer is right for problem 45, I got for your answer 97 and 715. So just a few more problems to do. And it comes from a set of problems that have a bigger table. So here's a table, and again, numbers were just completely made up, I'm sure. So refer to the table that shows the results of a survey regarding the type of cell phone owned by people who were interviewed. So men and women were interviewed and asked the type of cell phone they had. Most people had either iPhones or Galaxies, but some people didn't have those kinds of phones. And I'm assuming everybody had a cell phone. So if one person who completed this survey is selected at random, determine the probability the person selected owns an iPhone. To do this, the probability that you own an iPhone I'm going to form a fraction. The denominator of the fraction is going to be the number of people surveyed, which is 800. The numerator is going to be the number that owned an iPhone, which is 350. I probably could reduce this easily because I could reduce the zeros out and get 35 over 80 and then reduce by 7 by 5 and get 7 over 16. But that's dangerous. Why would I do that when I could just press buttons and avoid making a mistake on my videos, because I'm sure there's enough mistakes anyways. So 7 over 16 is my answer. For your problem 47, I came out with 15 over 32 as a reduced fraction. 49 and 50 are a little bit trickier. For 49, you want to find the probability, if you select one person from this group, that it's both a woman that doesn't own an iPhone. I know when I go to form my fraction, I'm going to put 800 in the denominator because there were 800 people surveyed. In the numerator, I need to put all the women that don't own iPhones. And the numerator for your problem is going to contain those women, because these 50 women that owned a Galaxy and the 175 that owned another phone other than an iPhone fit that they don't own an iPhone. I'm going to add the 50 and the 175, and I think I get 225. The fraction that I would form to do your problem 49 is going to be 225 over 800. And as a reduced fraction, I get 9 and 32. Just because I have a second, I'll do this one. If I want to find the probability that a person doesn't own a Galaxy, I'm going to form a fraction. It's going to have 800 in the denominator, and in the numerator, it's going to have the sum total of people that don't own a Galaxy. I'm going to add up the 350 between men and women that own an iPhone, and the 300 between men and women that own a phone other than a Galaxy. That's going to be 650. Of the 800 people surveyed didn't own a Galaxy. And my answer, if I was to answer question 50, the probability that a person doesn't own a Galaxy is 13 and 16. So that's about it for this section. You should definitely have this section perfected before you move on to 4.2. The sections build a little bit, and having this section perfected is certainly going to help your understanding of the next section. At least it's not going to hurt your understanding.